corrosion has been around for many, many years. Ever since we've had iron around, we've had corrosion problems, but we still haven't solved them. And this costs many billions of dollars every year in Malaysia and other countries. So it's a real big problem, not to mention the environmental aspects of having an oil pipe leaking. It's a little bit like CSI, if you like. You see the CSI on the TV where they go to the crime scene and they take lots of samples, put things in bags and things. We do the same type of thing, but it's not quite as glamorous. This is a cross-section through a weld. And it's a big pipe, about a 26-inch diameter pipe, and they're welded together using the welds like this. And sometimes these welds tend to corrode inside the pipes, and they can end up looking something like this. So you can see this was a welded area, and it's been eaten away by the corrosive fluid that runs through the oil and gas pipelines. So that's a big problem because it reduces the cross-section and it can lead to leakages, and also can reduce the mechanical integrity of the pipes. So when that happens, then there's a real risk of the pipes leaking, and then of course the product, the gas or the oil that's in the pipe, spilling out into the environment. So when things like this are detected, and it's quite difficult to detect them because this is the inside of the pipe, and of course you cannot get easy access to a lot of these pipes. But when they are detected, we go to the site and we try and find out what's causing it and make recommendations of remedial actions. So what we'd typically do is we'd go to an oil rig and we'd try and get the people who are our customers to leave the pipe intact so we can see the situation, the real situation. We would take, for example, something like this. This is another piece of pipe, and we'll take samples of the corrosion products on the outside surface. So by understanding those and applying various characterization techniques, we can find out what sort of oxides and carbonates, etc. are formed on there, and then we can try and relate that back to the corrosion processes that were happening. So by understanding what the corrosion products are on the surface of the pipe, inside the pipe, and also by looking at the production data and the general condition and characteristics of the pipe, we will be able to find out some information about how or what's been going wrong. We take samples of the corrosion products as well, and when we bring those back to the labs, we use some of our advanced characterization equipment to try and understand them a little bit more. But you can only understand so much by doing that sort of thing. So we also take samples like these ones, and we take them to the laboratory, and we try and replicate the conditions that are happening in the pipe. And if we can replicate the conditions, we can produce the same type of corrosion products on the surface. Then we can confirm that our theories are correct, and then offer better advice about how to mitigate the problem and prevent it from happening in the future. You can see inside there, the joint between this pipe and this pipe is corroded. And so you can see there's a big hole there, and that's obviously reducing the mechanical strength and the integrity of the pipe. So our recommendation to this particular company was that they apply this type of special glass fibre reinforced coating around the outside, so that it reinforces the structural integrity and also allows production to continue until they can fabricate some of these very special new replacement pipes. After that was done, they replaced the pipes with the new versions, which were a little bit more improved and a little bit longer lasting than these ones. And so we brought these pipes back to our laboratory so that we could carry on and do a little bit more investigation. So at that point it becomes not an industrial project but a research project. And so we use these real live examples of materials from oil and gas rigs to help us understand this corrosion phenomenon. And then next time the problem occurs, we have that little bit more information that we can help solve it and help mitigate the problem at an earlier stage next time. When a pipe corrodes, it creates lots of debris like these pieces here. These corrosion products can be quite hard, and when they travel down the pipeline and they interact with the pipe at a change in geometry, particularly a corner or a bottleneck, these things can impinge on the surface of the pipe and they can wipe away any protective layers that are on the pipe, and that can result in extremely high rates of corrosion. And these things are very difficult to detect because they're not actually happening at the site of corrosion. It washes down the pipe and then it erodes the surface of the pipe and the protective layers, resulting in quite a rapid failure at different parts of the pipe. And that different part could be several kilometers away from the source of the corrosion. Malaysia is a pretty much a hotbed for oil and gas activity at the moment. These kind of problems will happen in other places. It may happen at different rates, but they will certainly happen because the standards for welding are the same, the materials are all the same. The conditions vary, but in the end, these problems will occur in other places, and they do.